Hello and welcome to a lesson on the composition of the Earth. I have Selena here with me today, and we are really excited to review this work or have it be new work. Some of you, this will be new work. And so the other day you heard the story of the universe, and we talked about how all of the particles were given different laws to follow, different rules that they followed. And we talked about how one of the things that particles had to do is the heavy ones would sink and the light ones would rise. And we talked about that with the formation of the Earth and how the heaviest particles sank to the center of the Earth and the lighter particles floated on top until a crust was formed. And so today I want to talk more about what that Earth looked like, or what Earth looks like today even. And something that I wanted to share with you is a quick little experiment to look at the layers of the Earth in a different way. So I have some test tubes here with some different substances in them. Now, this one has a lot. This is water, and it has a lot in it. And this is a liquid, so it would flow down and out, and I could pass my finger through it if I could. So this one here is water. Now, the particles of water are all in here. I'm going to pour in, I'm going to pour in this one, and we're going to see what happens as we pour this one in there. So we've got our water. Make sure you have it high enough for you to see. We have our water, and now we're pouring this other substance in there. And remember, the particles were told to that they could attract to each other and combine to make new things.
That looks so weird.
Or they could come apart and push away from each other. And so I'm going to stop there. And we can see that as I put these particles in there, they didn't come together and attract to each other and form a new substance. They stayed their own substances. So we can see that the second substance, the new substance I added, sank straight to the bottom, that it did not mix with the water on there. So hang on one little second. I have so much water in here. Okay. All right, so we have our new substance. It was honey down here at the bottom, and here's our water. And we talked about the particles would come together if they were attracted to each other, or they would move apart from each other if they repelled each other. And so these ones, it seems that the liquid passed through the other liquid, but they didn't combine. They weren't attracted to each other. So I have a third substance here. I'm going to add it, and let's watch what happens. Okay, that third substance I added, let me get my shirt out of the way so you can see it against the white wall. You can see that we started with water, and then when we added the honey was so heavy it sunk to the bottom of the test tube. And then when I added this third substance, that was oil, cooking oil, vegetable oil, it stayed on top. So just like the layers of the Earth settled according to their weight, the particles settle according to their weight, inside this test tube, these particles have settled according to their weight, with the heaviest honey on the bottom and the lightest oil settled on top. So I don't think this was new for any of you. I think you probably all have seen this experiment before. It's something you can do, you can recreate at home. You don't have to do it in test tubes. You could just do it in a small drinking glass, and you just try some, with your parents' permission, of course, try some different substances, because you could do corn syrup, you could do vegetable oil, water, vinegar, molasses, honey. You could try it with lots of different substances and see where they go according to their weight. We see here the oil floated on top. Easiest to see it without the background. The oil floated on top, the water stayed in the middle, and the honey sank all the way to the bottom. So just like those kitchen examples, the particles that make up the Earth also settled according to their weight, with the heaviest ones sinking to the center of the Earth and the lighter ones floating to the outside of the Earth. I'm going to take you into a view so you can see a chart. And so this chart you've seen before. This is called the Barosphere Chart. There you can see all of it. And so those heaviest substances, the heaviest substances on Earth, when the Earth was just forming, all sank to the center of the Earth and created what's called the barosphere. Now, all of the layers we're going to talk about get their roots from the Greeks. And so the root baris comes to us from the Greeks meaning heavy, and sphere, sphera, meaning globe or sphere. And so this is the heavy sphere where the heaviest particles on Earth settled according to their weight when the Earth was forming. Now, when we talked about that, just like our experiment we just did, the heavy particles came to the center and the lighter ones were floating on top, and they formed what became the crust. That is this brown layer right around here. The brown layer is called the lithosphere. Hold on one second. I am going to label it on the chart because I don't think you can see this word down here. So the brown layer right here is the lithosphere.
It's almost off the screen.
I can fix that just like that. Okay, so the brown layer, the lithosphere, lithos comes to us from the Greeks meaning rocky or stony, and sphera, so it's the rocky or stony sphere. And so this is what makes up the crust. The crust is made of rocks that form a hard surface that make up the Earth's crust. And so this brown layer is showing us the crust or the lithosphere. And then the next layer, it's almost can't see it, this blue layer in there, it's a tiny blue layer, that's where even lighter particles floated to. So when we think about what's lighter than, when we think about the particles, we have the heaviest particles in the center, and then the rocky particles around the outside edges. And then what's lighter than a rock? Water. So the hydrosphere, oh, now you can see this part. There we go, hydrosphere. Hydro comes to us from the Greeks meaning water, and sphera, water sphere. And so this blue layer, it's so hard to see, that tiny little blue layer is the hydrosphere.
You can barely see it on the camera.
It's a tiny blue line. It's very, very small, very thin. Okay, now the last layer that makes up Earth, of the Earth's layers, is this light pink layer, and it almost looks white on your picture. This one on the outside, it's wider than the blue hydrosphere, but not as thick as the lithosphere. This one, I'll write it here. This pink one is the last layer. If we were to like jet off into space, the last layer of Earth that we would go through is the atmosphere. The atmosphere, atmos comes to us from the Greeks meaning vapor, and sphera, so vapor sphere. It is everything around us. It's where the clouds are, it's where the rain comes from, it's what protects us from the sun's rays. The atmosphere is where the wind is. And so the atmosphere is a pretty thick layer. When we think about it, it's pretty thick, that protects us. And it has a lot of work to do. And there's a lot of particles that make up the atmosphere. It's not just air.
Is it right here?
Yes, and it's right here. And it's even there and there.
It's up there too.
It's up there. It's everywhere around us. It's anything that's not solid or liquid that's part of Earth. Okay. I know that some of you, this is review for some of you, and some of you learning the roots of some of these words might be new. I'm going to rewrite barosphere large too, since I did it on everything else. Those are your 4 new words. Barosphere means heavy sphere. Lithosphere means rocky or stony sphere. Hydrosphere is the water sphere, and atmosphere is the gas. The gases that make up all of the air we breathe.
Solid liquid gas.
Solid liquid gas. Ooh, I have a lot more lessons about the barosphere, and we'll learn about whether it's a solid or a liquid or a gas.
I think I know.
The heavy sphere, just like these layers, the center of the Earth is the heaviest particles to the lightest particles. Each of these layers also has layers. So the barosphere isn't all the same all the way through. Scientists have many ideas on what they think is in there, although we have to make guesses because we can't get there. But each of the layers has different layers, and we'll talk more about that as we get further in. So I hope that you enjoyed your review or new lesson about the layers of the earth. And I hope that maybe you will try to make your own experiment showing the different weights of different kitchen liquids at your house. I can't wait to see how you follow up and share your learning with me. I hope you enjoyed this lesson, and we'll see you next time. Bye-bye.